Hello, everyone. Welcome to the SingleStore introduction webinar. My name is Kong, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you're currently in a listen-only mode. You can submit questions using the Q&A function in the lower right corner of your console. We will answer your questions at the end of the session. And after today's session, you will receive an email with a link to the recording. If you wish to contact us, please email us at team@singlestore.com. So a quick introduction of our speakers today. Domenic Ravita, VP of Product Marketing, has close to 30 years of experience in data infrastructure. Domenic is a musician and an avid soccer fan. Vijay Raja joined us in November as the Director of Product Marketing, after spending the last 5.5 years with Cloudera, leading their industry and solutions marketing. Vijay has over 18 years of experience in IT and in the data and analytics space. Vijay loves fine wine, playing with his kids, and Ohio football. Welcome, guys. You now have the floor.
Thanks, Kong. And thanks to everybody for joining us today. We're really excited to present an introduction to SingleStore. And we'll spend the next 35 to 40 minutes giving you an overview, and we'll have a Q&A at the end. So with that, let's get started. First, it's important to understand where data is. In the last several decades, we've seen quite a lot of disruption in how data is delivered, how applications are built. And just in the recent cloud era, in the last 20 years, we've seen quite a lot of change. And what we've seen, and you've seen this in your own applications, is an adaptation to new challenges. At the database layer, at the data tier of applications, the first response to this in this first era was to take existing single node traditional databases like MySQL and Oracle and Microsoft SQL Server, and to scale them through sharding and partitioning and basically adding another middleware layer on top. And this met some challenges, but it had a lot of drawbacks in what was possible. But in the early wave, we were doing a lot of this as an industry on premise. And then cloud started to take control in a more pervasive way. And we came to adopt technologies that could give us speed and scale. And we could meet those internet scale sorts of web applications by breaking the constraints. And the so-called NoSQL sorts of data stores began to proliferate. In-memory key value stores, separate data stores for doing full text insert searches, other types of data stores that were wide column stores. And so more and more it became a data store per workload approach. And you could do this in the cloud, and it provided you this elasticity. And you had this speed and scale. In this time period, we all started to see the adoption of new kinds of technologies for data lakes, whereas in the past, the data lake had been generally on-prem, generally built with a distributed file system and storage system like Hadoop, and then we were layering technologies on top of that kind of data lake. So in the last decade, we've seen the modernization of the data lake along with other types of data stores that are happening with the transition and greater adoption of cloud in the enterprise and across our businesses. In the last several years, we've seen this return to SQL in a way, to basically give speed and scale and SQL without giving up the constraints. So having your cake and eating it too, basically having the best of the data styles and access patterns and data structures of the various types of SQL data stores, but also with fully distributed native SQL. And the benefit of that is that you can do robust analytics, interactive queries. It works with all your BI tools. And we've seen as this growth in real-time use cases. Real-time in the previous eras were more niche use cases in particular industries like finance or cybersecurity, we're seeing a huge growth right now in real-time data. And that's from a couple of different angles, and I'll cover that in a second. We're also seeing adoption of multiple cloud environments, either by design or somewhat by accident, to provide flexibility. Your companies typically are choosing a cloud service provider like Azure or AWS, but then you get other clouds environments which perhaps you didn't intend to take on, like through your CRM application like Salesforce and others. And so when you put the SaaS applications you're consuming along together with the infrastructure cloud services, you have a multi-cloud environment. Often now you're trying to bridge data across them. And then finally, you're still making use of data in multiple models, a relational model, maybe a graph model, and inverse indexes, data structured in different ways for different use cases. There's quite a need to be able to have that flexibility. So quantifying what we see in the adoption of these trends, of course, there's been a huge adoption in public cloud now in recent years for data and analytics. And Gartner has cited this in their top 10 trends, and you can find a copy of that on the SingleStore website. Secondly, many of these workloads are predicted to move into a hybrid realm, because once you have these different SaaS applications and cloud infrastructure environments, undoubtedly your business processes cross each of those different domain areas, and you need to share data across these. And so there's a multi-cloud view of that, but also workloads tends to drive hybrid cloud and hybrid workloads. And then finally, the growth of real time. And this prediction by IDC is that nearly 30% of all data generated will be of a real-time nature, or you're going to be utilizing that data in real time. And so these are just some of quantifications of the trends that we pointed out earlier. But what's the problem that we're still dealing with? Well, it's multifold, and it comes from just the deluge of data. It's also our reaction as an industry of continuing an approach from sort of the previous era of picking a data store per workload. And so now we have this proliferation of multiple data store types that each of them require their own skill set. We're dumping data into data lakes. Now they're in object stores, and it's a little bit of the same pattern of the previous Hadoop era, but now we're dumping data in the cloud, and we're trying to make use of that data in a modern data lake. Ultimately, it's too much to deal with too many moving parts to deal with this effectively, to provide information in the moment, and to provide low latency data for your customers and applications. So at SingleStore, we're focused on breaking these bottlenecks so that you can grow your customer base. So if you're a startup and you're building a new app and you're looking for what's the data tier that's going to scale for these diverse workloads, SingleStore is built for this cloud native environment for elastic scale. And we are expert at delivering this data in those moments that matter. If you're talking about a customer-facing application, maybe it's a real-time API, maybe it's analytics for portfolio or wealth management, or it's internal and you're trying to provide operational efficiency for supply chain analytics. SingleStore gives you the flexibility of these various styles of workloads with data types and access patterns from the NoSQL area, but also the familiarity and compatibility with full ANSI SQL support and distributed scalability built in. So we're doing this now for a growing set of customers, and you see this quite a lot across different verticals, both large and small customers. So with that, I want to hand it to Vijay to describe a little bit more about what SingleStore offers.
Awesome, thank you, Dominic. If you can click through the slides, Dominic, Okay, great. So hello everyone. Great to be here again. This is Vijay. I lead product marketing, work closely with Domenic and the product management team here. So how do we what do we offer in terms of SingleStore, right? The way we define what we do today is what we offer is a unified database for fast analytics on any data anywhere. So we're talking about a unified database for fast analytics on any data anywhere. What do we mean by each of these? We'll break it down. And so that's what we offer. And if you can click through one more time, Domenic, and who do we do this for? Is Domenic, kind of flashed a few logos there, but we do this for half of the top 10 banks and financial service institutions around the globe, tier 1 telcos and media companies, right? Technology streaming companies, Fortune 500 leaders, and also tech visionaries from Uber to Akamai to a number of disruptors, if you will, in the industries, right? And again, what I said is we'll go back to what we mean by what do we mean by unified database and what do we mean by fast analytics. So Domenic, if you can move to the next slide. So what do we mean by fast analytics? What we really do is we offer the speed, scale, and agility to power a few things. Number one, we power modern hyperscale applications. So these are tier 1 applications where complex decisions needs to be made immediately based on streaming data, based on real-time data, right? And the way we can categorize your modern hyperscale applications today is really, you have the internal facing applications or you have the external customer facing applications, right? And the way we define that is can't wait analytics and won't wait customer experiences, right? So can't wait analytics is really, the business facing or the internal facing applications and dashboards that you have today, right? Where you need super low latency, high concurrency, that utilizes both real-time as well as historical data, right? Examples could be, tier 1 banks doing, fraud analytics applications when you need to act in the moment, right? And leading tier 1 banks are actually utilizing SingleStore to kind of identify fraud in real time, or to power cybersecurity for that matter, right? For all of them, you need to be able to, stream a lot of data and do anomaly detection or predictions in real time, right? Another example could be telcos doing network analytics to understand network usage patterns and traffic in real time. Or, one of the leading mobile phone companies, they are doing real-time supply chain analytics dashboards using SingleStore. So all of these are great examples of what we call the internal facing can't wait analytics applications, right? On the other end, you have what we call the won't wait customer experiences. Think of these as the customer facing applications where speed and personalization drives everything. Examples include Uber, obviously, everyone knows Uber. They're able to manage things such as manage surge pricing in real time based on the traffic and on the demand for a specific location, right? Hulu, another one of our customers, they're able to improve the customer experience by minimizing buffering issues and to do real-time monitoring of the video stream quality, right? That's another example. Similarly, like top 10 wealth management firm, they are able to offer real-time portfolio analytics and interactive dashboards to their high net worth customers. So that's a whole set of applications, modern hyperscale applications that we power. That's number one. Number two is what we power is using speed, scale, agility is what we call the predictive analytics, right? So there are a number of customers who are using SingleStore to operationalize machine learning models at scale across streaming and historical data, right? So this really comes into perspective when you have to do model scoring and calculations in real time on new data streams that flow in continuously, right? And what that means is what we enable customers to do is give them access to more data in real time to do real-time model scoring and calculations. And examples of these include organizations such as Epigen, who's doing real-time facial recognition based on the video streams or the image streams that are coming in. Another example is Thorn. If you have not heard about Thorn, I think it's a fantastic use case. You should check it out. They're really helping identify child traffic and trying to put a stop to child trafficking. Again, trying to identify kids based on the images and the images that fly in, right? So that's kind of the predictive analytics category. Last but not the least, what we power is also IoT analytics, right? This is all about how do we ingest data in real time, streaming data from sensors using Kafka, and being able to do real-time analytics to further understand the trends, spot anomalies, and even predict outages, right? And we have a number of customers there who are using us for IoT analytics, including some of the leading energy, utility, and oil and gas companies, right? So those are kind of the three broad categories of fast analytics use cases that we power today. If you can go to the next one, Dominic. Yeah. So if you look at the customer base, right? I think I spoke to some of these. Uber, as I already spoke about, they are bringing in real-time geospatial insights, with massive concurrency to basically understand where each vehicle is in real time, and to manage things such as surge pricing based on the overall demand in real time, right? The tier 1 US bank, they are using us to do real-time fraud analytics on each and every credit card swipe that happens. So for example, they have about a 50 millisecond window to determine if a swipe is genuine or fraudulent based on querying about 70 different parameters. Imagine that, 70 different parameters, querying that in real time, within a 50 millisecond window to make a decision, right? Those are the type of use cases that we power today, right? Akamai, another great example. They are, again, one of the leading global content delivery network, providing web and internet security services. What they needed to do was they needed to move away from monthly billing to what we call daily or even hourly billing, right? That's the new model that they wanted to get to. But that new model, what that meant was that new model will generate 10 to 13x more data than they're used to today, right? And so however, that, what does that mean? They used to have a batch process and used a legacy database, which was really unable to scale based on the exponential data growth that these guys were going through, right? The batch process no longer works. They needed to move from a batch to a near real-time visibility and analytics, right? And that's really why they moved to SingleStore, to accommodate this 10 to 13x data growth. And what they were able to do is they switched to SingleStore, and they were able to improve query performance by 96%. 96%. They're able to do over 10 million upserts every second, which is almost 100x faster than what they were able to do with Exadata with Oracle today, right? So it's not just about the speed, it's about speed, scale, and agility that we bring together for these leading organizations to power some of these most compelling use cases. And again, there are examples in energy, utilities, telcos, so on and so forth. But I hope this gives you a sense of the very interesting set of use cases that we power today. Back to you, Dominic. I know you want to go through a little bit more on the details of the product, so I'll swing this back to you.
Great, thanks, Vijay. So I'd like to cover a little bit on breaking down each of these areas. So Vijay talked about speed, scale, and agility. And if we look at what we're providing in terms of speed, we mean that from multiple perspectives. First, ultra-fast ingest. If you're not able to ingest the data in parallel at speed, then right away your latency is determined by that. Forget query processing downstream from that, how much volume that takes. All of these things need to be working in parallel at speed. So the way that we provide ultra-fast ingestion, typically we're seeing distributed data sources like Kafka and Spark, and we make parallel connections into those distributed data sources and can ingest that data ultra fast. And that's typically where you find the bottleneck in other data warehouse, cloud data warehouses, as well as traditional on-prem databases and appliance. That's one of the bottlenecks that we break. We're ingesting that in super low latency, so immediately as the data streamed in, you can operate on it. So you can perform streaming analytics on this basis, but do it with full the power and semantics of full relational SQL. Or if you're just doing, if you're updating data and you just want to fetch that data through an API in like a key value kind of document oriented way for a product catalog, it's immediately available. And so we mean speed in terms of speed of instant access as well. And then thirdly, when we talk about speed, we also mean in time to delivery of the data for your product. If you're building a data app and enriching it with embedded analytics in your React-based UI, It's super easy to get started. We've got a lot of videos on our YouTube channel that demonstrate how to do this. Our documentation is fantastic and can get you started really quickly. I'll describe a little bit more how to do that later in the session here. Also, we are, let me progress the slide here. There we go. We'll go back. Now talk about scale. And again, we mean this from a couple of different perspectives. First, let's just talk about the scale of data. Data sets are growing and getting faster and faster, and we want to, as businesses, retain that data to do lots of analysis on the operations of our business. We want to do customer analytics at scale. We also want to monitor our networks, and we want to retain this data so that we not only can operate in the moments that matters for our business or for our customer, but also see how that compares to trends over time and retrain historical data. So with SingleStore, you can run this in your environment anywhere, cloud or on-premise or in hybrid, at petabyte scale. And I'll describe a little bit more about that later. Secondly, high concurrency. Often what needs to be scaled, maybe your data set itself for your application is not growing really fast, but it's just the speed, the number of users who are, need to access it. Your app may be a customer-facing app, and you're being super successful in your mobile launch, and now suddenly you've got API calls from your mobile apps or directly from end users or both, and you need to quickly scale that concurrency on this fast-moving data. And SingleStore is ideal for this scaling use case as well. And then finally, elasticity for just monitoring your cluster and scaling that up and down based on your needs. And SingleStore Managed Service makes that easy to do. So finally, with agility, we think about agility. Let's progress the slide. There we go. As helping you to move more quickly in the direction of the changing business demand. And so going back to what I mentioned earlier on the 3 eras that we see in the cloud data evolution, if you have an approach of a data store per workload, your ability to turn on a dime to capture new business opportunities is going to somewhat be inhibited by that different collection of data stores for each part of the process. So with SingleStore, because we synthesize these different data models, data structures, data access patterns by providing things like JSON as a first-class citizen. So you can do classic document object store kinds of use cases or document use cases like product catalog in the same place that you're doing analytics on that application. So you don't have to go to a separate store like a document data store and then do ETL and copy and move that into a relational store. You can do both in this synthesized, combined, unified database for fast analytics. Any data, what we mean by any data is that it's your unstructured data like raw text, binary large objects, as well as your maybe semi-structured data, which I would classify as JSON and document types. And then of course your classic relational data. And you can combine, when you store these different types of data in SingleStore in its distributed native environment, you can scale compute and storage effectively to meet those use cases and join across these different types of data. You can join JSON data with relational data. You can extract using filters or where clauses, predicates directly into your JSON columns and create, optimized columnar structures for analytics on that without having to copy and move that data to an external source for a different data store to perform that. So you get a lot of flexibility here and agility within that. And then finally, you can deploy this in any environment and access it through your typical tools, Tableau, Click, typical Spotfire, etc. So when you look at this all together, this is what we mean when we talk about scale, speed, and agility provided by SingleStore. And so here with SingleStore, I want to point out some unique combinations of what this means. Not only when we're combining these different data types together, but we're providing a greater flexibility and agility in the spectrum of workloads. So whereas the previous era that we pointed out earlier in the presentation about sort of that middle era where we were adopting NoSQL stores but picking a data store per workload, with the technology of a unified database with SingleStore, you can use one database to do both of these kinds of workloads of an operational database and a data warehouse. And so we can give you the fast lookup and the types of OLTP workloads for highly selective single row lookups, which is common, as well as very fast non-blocking writes. And SingleStore provides a lock-free structure to allow super fast writes. With the workload types you typically characterize for a data warehouse, where you're doing queries on large complex aggregates, or you're calculating the aggregate, but now you want to be able to get more frequent computations of the aggregate. And that's typically where data warehouses, both on-prem data warehouses that are appliance-based, but also new cloud data warehouses, this is where they start to struggle. This is where you start to see things like Snowflake, Google BigQuery start to struggle to provide low latency analytics on these kinds of use cases. And so SingleStore can provide a solution to combine both of these and reduce the number of different data stores you use for these use cases. So how do we do this? We provide something called universal storage. And it's an evolution that we developed from our dual store. And you will find sort of a subset of databases out there that provide in one database an in-memory row store and also a column store. And typically you'll find the in-memory row store is targeted at use cases that are OLTP. That allows you to do really fast writes to data with super low latency response times. And then with column store based applications, you get compressed data, you can have much larger data, higher compression ratios. So we've provided that for a number of years, and there's a small set of databases out there like SAP HANA that basically provide what you see on the left. What's unique to SingleStore is the fact that now we've combined these types of benefits of these two different types of storage mechanisms into one storage mechanism called universal storage. And originally, for those that are familiar with the company, we called this technology SingleStore. We liked it so much, we decided that we would change the name to SingleStore, because under the covers, we're still providing an in-memory row store for you for those use cases, and we're not going to get rid of that. We are providing the memory and disk column store. What's different about SingleStore is that it's becoming our default table type. So when you do a create table DDL, data definition language statement, and you're defining that table, the default will become that column store, because for most situations, you'll find that that's the best case, even if you have an OLTP-like workload. And we are, our part of what we're doing, the ability to do fast ingest, to do highly selective OLTP queries, but then also to do these really large complex aggregates, is we're using a combination of these capabilities all in universal storage and making that very easy and super accessible to you. So on the far right, you see the kinds of benefits of this. You're no longer ETLing to a separate store. So if you have a use case where you have a transactional cache or an in-memory key value store that you're providing to back an API or to back some really fast transactional application, typically you would then ETL from that or write it out to a relational store. With this approach, you can keep that data as it lands in SingleStore. You can operate on it within the cluster, and we support common capabilities in databases like stored procedures. So what you can do a fast ingest from a SingleStore pipeline and directly ingest that into stored procedures and do the computation in cluster or inside the SingleStore database cluster. And so that's why we say we can reduce or eliminate the situation where you might be using ETL in that scenario. It's a simplified architecture because it's combined. It's lower cost in terms of the number of data stores you need to manage and the skill sets you need. And of course, you're going to get lower latency from all this. So bringing this all together, this view gives you a quick overview of what we've discussed so far, and that you get in SingleStore a unified database for fast analytics that operates on any data anywhere, and it gives you simplified access for applications for real-time decisions. And on the right, through, if you're building a dashboard or some other sort of real-time view, which we like to call fast boards, we can help accelerate your data layer. So it's not an all or none approach that you must move to SingleStore. We've got lots of scenarios where we're working as a complement to an existing OLTP database like SAP Sybase, for instance, or MySQL, but also where we're complementing cloud data warehouses to provide that fast access to, for analytics, low latency analytics in front of those. And we run everywhere. And that's what I'd like to discuss a little bit next, is how we provide that. So there's something a little bit out of order here. Let me cover this first, and we'll get back to that. So where does SingleStore fit in when you look at your existing types of data stores? And we put these in different categories. So when you start on the left here and you look at what we are calling incumbents or legacy data stores, SQL Server, MySQL, Postgres, these are examples of 30, 40-year-old technologies that are built around a single node. In other words, they're not built distributed native. And I want to distinguish that from that first era that I talked about at the beginning of the presentation, because we find that there's lots of examples where a single node database like MySQL is taken and then sharding middleware is used to scale it up. That works at a certain level as sort of a short-term band-aid in some situations, but you typically get other sorts of bottlenecks. And one of the bottlenecks that still doesn't typically solve in a good way is the streaming ingestion. You still have that bottleneck at the ingestion layer. It's still limited on the concurrency you can do. It becomes pretty cost prohibitive, and you don't get great price for performance. In the second category with cloud databases, and we give some examples there, some of these are built on single node databases that are just using sharded middleware and running them in the cloud. Some are natively built from scratch. It's mixed depending on the type of cloud database. When you're talking about low latency queries for analytics, you'll find that you're not going to get the performance that you need. And so one I'll point out here is Nucleus Security, who migrated from MariaDB onto SingleStore for basically providing cybersecurity for infrastructure and DevOps. And as that use case has expanded in many businesses, there's more diagnostics and vulnerability detection that's important. And so a bigger set of data moving faster, that's how they're using SingleStore to break the bottleneck that MariaDB had presented. And then with cloud data warehouses and specialized NoSQL stores, again, the theme is the same, that we're providing you a speed layer to access low latency analytics for each of these, while not giving up on the kinds of flexibility that you want with data structures and data access styles. So how do we deliver SingleStore? There's two ways we deliver it. First, through SingleStore Managed Service, and that's fully managed on-demand cloud database service. And then secondly, through SingleStore DB, which is self-managed. You're running that in your environment. You decide how to run it, and you're running the infrastructure, right? So a little bit more details on where we're providing this. We're providing this in AWS today. We're providing in Google Cloud Platform and Azure. And with SingleStore Managed Service, you also have the ability to run this in a hybrid fashion. And basically, whereas managed database as a service is we run it in and we are the cloud operations. We provide the cloud operations for that environment. With hybrid, you get to choose where you would like the data nodes to run. You can run it in your AWS VPC, for instance, yet still have software as a service for the administration. And SingleStore Cloud Ops can also help to administer that environment. So it gives you the best of both worlds in terms of where you want to draw the line on control and flexibility of your cloud database. And this is fairly unique in the industry for us to provide this type of hybrid managed service model. Again, if you want to run this yourself on your own hardware for various reasons, there's lots of businesses that may still do that for their security profile, but perhaps you want to run this in Kubernetes on or an OpenShift. We provide both a Kubernetes operator to do this. You can get that in the OpenShift environment through the Red Hat marketplace. And also we provide Docker images to do this. And there's lots of documentation on this and videos on our YouTube channel. I advise you to check it out if that's what you're looking to do. So how do you adopt SingleStore, and what are sort of the patterns for that? And I would break it down into 3 simple ways to look at this. Firstly, building new applications. If you're building a new application, you're undoubtedly building that in some cloud environment today to take advantage of the unit economics for the app, the skill set, but also the security that the cloud can provide for these apps and the accessibility. And so you can find this in the AWS marketplace, for instance, and you can directly build this from day one with SingleStore. And where you might have used something like Mongo and Redis and a relational database, those 3 types of use cases, those 3 types of data stores, you can build on day one to handle transactions, analytics, and these kinds of document use cases all in your app with SingleStore. Secondly, augmenting existing systems that you have, whether you're augmenting your OLTP database, and often you don't want to touch that database because it's highly critical to your business operations. So your first step is just to take off through CDC, change data capture, and then do analytics, off of that analytical or transactional data store. And we see that as a common pattern. And we've got partnerships with various different change data capture providers, and we provide our own ability through SingleStore Replicate to provide that CDC from your OLTP source. The second way to look about augment is that perhaps you have an analytic, cloud data warehouse, but now you need real-time KPIs that you need to aggregate, and you need a way to provide low latency analytics, sub-second response times on queries at high concurrency. Again, you won't find Snowflake or Google BigQuery able to do that, and you won't be able to get it through tweaking and tuning that. So we have lots of situations where SingleStore is used to augment those cloud data warehouses and to put it in front. So we receive the real-time stream of data from Kafka, Spark, etc., and provide that real-time analytics. Finally, modernizing or replacing what you have. So if you're using Hadoop and you're looking to provide the new answer to the cloud data lake, often we're part of that solution to provide a data lake that's operational, a way to operationalize that data lake in the cloud. Again, we can ingest data from object stores like AWS S3, Azure Blobs, Parquet files, etc., just the raw files on file systems, etc., and operate on that data instantly. And so often we're used to modernize the data lake, to modernize the data warehouse, and to modernize the transactional OLTP databases. So in a nutshell, the 3 or 4 things that make SingleStore the best for your use cases when you have a combination of these items, that you need to provide low latency ingest for super low latency queries at scale for many users, and it's operating on dynamic, fast changing data. These are the ideal situations where you want to start first with SingleStore. And I mentioned before that we're used across different verticals and different industry use cases. We touched on that, Vijay touched on that a little bit earlier. This is a sort of the next layer down on the kinds of use cases that we have current customers, and this list is growing daily in terms of the use cases that we're in. But if you look at these, you'll see where the real-time analytics matters, either for the customer experience of what's being delivered to your customer or partner, and that's in sort of an external view, or it's internal. You're optimizing the business. You're trying to provide operational efficiency, and you see that, for instance, in the technology where you're looking in the technology area here for supply chain analytics. So how do you get started? First, I'd say that we provide lots of different ways to learn, and you'll find that in our docs. The docs are very thorough and complete. If you see something that's not there, we'd love to hear from you. Secondly, you can engage peers in our community by going to singlestore.com/forum, or go to the community hub, which you'll find at /community-hub on our main website. There's quite a lot of video content where we publish new videos every other day that shows customers speaking about how they're using it, as well as how to perform, how to use features of the product, how products are used in solution architectures. And you can do a free training at training.singlestore.com. I would think a lot of you, if you're a developer or a data professional, you like to learn by doing. And so there are 2 ways you can do that. And that's what's shown here on the right, which is you can instantly get started with $250 in free credits for the managed service. And you can spin that up in your cloud provider of choice, AWS, GCP, Azure. Or if you have a laptop and you like running things in Docker, you can go to this link at the bottom, download it, run it in Docker. And you can run SingleStore DB in self-managed way in production. And we've got our set of community users out there. Many of them are doing production applications for their businesses on SingleStore DB. So with that, we'll move on to the Q&A, Kong.
Sounds great. All right, as a reminder, you can submit questions using the Q&A function in the lower right corner of the console. So let's begin with this one. Do you support OLTP applications such as a .NET application?
Yeah, most definitely. I haven't mentioned this previously in this session, but SingleStore is MySQL wire protocol compliant. What that means is that any language you choose, there's a language binding that allows you to directly connect from that language to SingleStore. So for instance, with .NET, you can use the .NET MySQL connector and connect right away. Our developer advocate, Rob Richardson, has published a video on this recently on our YouTube channel where you can see connection from C# and .NET directly into SingleStore.
If I compare SingleStore to virtual databases like typical data virtualization or Denodo, what is the main benefit?
Yeah, so that's an interesting question. Data virtualization is a technique. Sometimes you see it called federated SQL queries, or sometimes you'll hear it called, it's often used these days with data lakes. You may hear it called a cloud data lake engine or a SQL engine for data lakes. Basically what that means is you've got the storage in files, and the files happen to be, these days, typically these files often are in the cloud in object stores like AWS S3. But often there's a lot of files on premise. And the class of technology, which I'll call data virtualization, allows you to access these heterogeneous different types of data sources, files, and databases, as well as different types of data structures like comma-separated value files, etc. And then what it does, it tries to provide you an analytic types of queries, historical, after the fact for a business analyst typically, and tries to move as little as data as possible. The thing is, when you're joining data across these sources, you have to bring the data together somewhere to do the join. So typically that happens in the, if the data you're joining is across from two different sources, like a Teradata and your data lake object store, for instance, you've got to bring the data in to join it somewhere. So these tools are very good to get started building maybe a prototype for an analytical dashboard. Maybe you're building something in Tableau and you just sort of need a quick and dirty to see what's possible if this has the right data. They're excellent for prototyping like that. Often those apps might start to serve a few users, 5, 10, 20 concurrent users. They tend to be fine for that. But once you're now trying to serve, operational data for a highly concurrent set of users, and the data is fast changing, that's when these data virtualization tools no longer really provide a good answer. In other words, they don't provide fast analytics, is the nutshell. And that's where you want to look at a technology like SingleStore, because we can ingest data from all of these sources that I mentioned just now, files, object stores, Teradata, Mongo, other types of stores, and provide real-time analytics on that data as it's changing. So I would say in general, these tools are complementary. They're used for different purposes.
Do you support vanilla Kubernetes setup, not OpenShift?
Yes, absolutely. You can run us, and we've got documentation on how to set this up in Kubernetes. We're not tied to a particular, and Kubernetes is meant to really be agnostic in that way, but we're not tied to a particular distribution in terms of Red Hat or Google's distribution of Kubernetes. You will, of course, be taking on more of the configuration responsibility, setting up your YAMLs and your configuration sets and pods, etc. But if that's the route you want to go to, absolutely, you can run SingleStore in a Kubernetes environment.
Do customers replace their data warehouses with SingleStore? How are customers adopting SingleStore?
Yeah, good question. I would go back maybe to this view of how customers are adopting SingleStore, and it typically falls into one of these three areas. So the question is about the last one, modernizing or replacing their data warehouse. We do find that. It's not the only way to adopt SingleStore with data warehouses. Often we're augmenting. But in the places where we're replacing the data warehouse, sometimes it's because the cloud data warehouse chosen initially, it wasn't understood that it couldn't provide sub-second consistent query response times for real-time analytics. And that's discovered as they use and build out with the cloud data warehouse. So sometimes we're replacing it in that situation. Sometimes the situation is being replaced because the data warehouse is an appliance-based data warehouse, and the strategy is not to continue to build out that further. It's to go to a modern data warehouse and a different architecture. So the evaluation is opening up new technology for the data warehouse. So in that case, I would call that more of a modernization kind of story, and we definitely are replacing things like Vertica and Netezza, for instance, with SingleStore as a cloud data warehouse use cases that require these real-time, low latency responses.
Last one. Can you touch a little bit upon how does SingleStore replace the need for NoSQL databases?
Sure. So let's cover a couple of examples, and we've got deeper materials on this on our website and YouTube channel. But let's just take something like a document style use case, and how it is that you start. You may have started in the last few years, if you're building something like a web application. Conventional wisdom for developers says, well, use something like a document database, like something like Mongo. And why would you do that? Because it's super convenient. With just a few lines of code, JavaScript often, you can store your data and fetch your data. And for highly concurrent, scalable web and mobile applications and API backends, this is what you want. But as your application gains adoption and you're building new features into this application, then there comes a time typically where you need to provide more complex query types, where you need to do analytics. And when you get into this area, this is where document databases simply don't provide good answers, because they are objects. The documents are objects, and you have to create collections of objects to make that perform. Now you basically have to essentially materialize the Cartesian products or the joins of these data in the database. That's one way to do it. Often you might just do an ETL out and provide an analytic data store that can do the join. And so what we find is that with these kinds of use cases, we can provide the answer for the starting use case, which is as a document store or as a key value store, and provide the speed and scale needed on day one with that. And day two, when you're trying to do analytics, you don't have to migrate to a different approach, a different data store. With SingleStore on day two, it has all the analytics available there. So I would say that wherever you start with your workload or use case, you can go to many other types of workloads and use cases with SingleStore. You can't do that with specially purposed NoSQL. They are built for speed and scale, but for a very narrow workload. So then you now have to add complexity by copying and moving the data to another data store, typically a relational type of data store. And now your infrastructure is more complex and you have two. So this is how you can, start with something that's more flexible from day one. But also, if you find yourself in that situation, you can replace your document store with SingleStore.
Great. Those are all the questions for today. I want to thank Domenic and Vijay for the presentation. Thank you everyone for attending and asking all the great questions. Just a reminder, we'll send you an email with today's recording. We'll also like to invite you to our real-time analytics webinar next Tuesday and the Cloud Architecture Summit next Thursday. You can start a free trial today at singlestore.com or reach out to us at team@singlestore.com. Thank you so much and have a great rest of your day.